What we'll do is we'll start with what the product has today and what are some of the features that we have. And one of the other things we'll do is also look at some of the new features that we are developing that will be part of the next release as well. I'll show you some screenshots of the UI that we are building. If you have any questions in between, please feel free to ask at any point in time. So the idea of this product is it's basically a product to enhance data quality for organizations. And what we do is typically build a system that can, what should I say, create systems that can handle bad data, which means that in a given data source, from a given data source, it can extract bad data and eventually quarantine it and move the good data to the destination, whether it is a external system or it is the local system within our server. So this is the premise with which we have built the product, and there are multiple components in this. When we call it a workflow at this point in time, you can create what do you call multiple nodes. You can create data cleansing nodes. You can create custom models. So what we'll do over this demo is that we will look at all these in different examples, features, and we will see how they work and some of the interesting aspects of what we built. So what we'll do here is that we will now first create a data source to identify duplicates. Basically, the idea here is that you can upload a data source. You have the capability to write custom script in SQL, R, or in Python, okay? And you can upload that, okay? And what you can also do is then post apply recipes. So here we have a whole bunch of recipes that we have. Some of them are it's split into multiple areas: data operation, validation, table operation, rev columns, etc. In this case, what we'll do is we will try to find duplicates within the system, and we have basically a ticket validation data. Okay, ticket data from a CRM system that we've as a sample data that I've got today. Here we say that the duplicate columns are going to be columns based on the same title, and the distinct column is going to be an incident number. You can have multiple distinct columns. You can have multiple duplicate columns as well for validation. Okay. Now we will have a look at these. What the system will now do is that it will go and try to segregate the duplicates based on the columns that we've selected. You can look at the data right now. What happens is that you find all the duplicate errors here, okay? And you can look at how all these duplicates have been created. You can, based on the title, okay? You can see all the duplicate data, okay? And these are all the errors that have been created. The final data is now has been moved into the system. So what you see here as the final data is basically the ones that are not duplicates, okay? And this is the good data that is eventually stored in the data source. We will now go to the next one, where I'll show you one more example of validation, okay? So what we can do here is that we are feeding in basically some retail data, okay? We split this data into multiple domains so that it is easier to understand also, and it also fits the use case very well. So what we will do here is we will apply a custom rule wherein we specify what is the logic behind this particular rule. I'll tell you. So we are saying this is basically a retail data where you have products of clothing, okay? And we are saying that this particular, there's a column called age, which is typically the age of the product, how long it has been since it was manufactured. we're saying that the age cannot be more than 600. So product age cannot be more than 600. Okay. And we're going to execute that. We're going to say, okay. Now what we'll do is, if you go look at the errors now, there's something called product age out there. And there are about 685 errors. Now, when you go look at the errors, all this basically has product age more than 600. Okay, what you see here. We have something called root cause analysis. This is the latest feature that we've added into our product. Basically, what it does is it goes and does product pattern matching to understand why these errors are happening. Okay, and this is completely written in Python. Without any external software, third-party software. It is purely a Zscore. It is one of our IP that we are writing right now. So what it does is it basically goes and does pattern analysis to understand what are the new patterns that could be available. And it says that there is something called basically there's something called an invert doc number within this in this data. Okay, the invert doc number basically is, it goes and analyzes. So what this basically does here is that we go look at the old data, the whole data, and the good data and the bad data, and we understand what are the patterns that are causing this particular error. In this case, we figured out that when the invert doc number is less than or equal to 8543 and the design number of the product is not ADI fresh, then the product age is always, it is only then that the product age is always more than 600. Now, this is very crucial because when we start generating errors in millions and millions, it is very difficult to go and fix them without knowing what is the root cause. So the root cause here has to be, and we also specify what is the chance of this occurring. The chance of this occurrence is at this point in time 98.49%. Okay, so I'll give you an example. At our customer's place, one of our healthcare health insurance customers, we've processed close to about 500 million rows of data, and about 165 or 170 million rows of errors are there. So it's very difficult to go and fix 170 million rows. And even if people are going to fix errors, they go and just fix that particular value where the error is happening. Okay, they don't understand why has that error been caused. So the error never gets fixed. It is just corrected at that particular instant. So the next set of errors always keep happening. And that is the reason why we are doing root cause analysis, and we specify, we tell the user, this is exactly the reason why it is happening. Why don't you go and analyze it? The action based after this particular, analysis is that users can go and you can go and email this to anybody, to the corresponding person. You also have the capability to bring people within the system and also fix the error then and there itself. Okay, if it is our system, then it can be fixed. If it is an external system that needs to be logged into, then if the the access is provided, then we will be able to do it as well. And the second portion is the collaboration feature that I was talking to about. It's a very, very important feature in the product, and we believe that it is crucial for data quality to succeed. We will be releasing it in about 3 to 4 months' time. Then we have, I'll show you another example where we do analysis of geographical data. Currently, I'm going to show it to you for India. Since most of all our customers are Indian customers, we are only doing it for India at this point in time, but we plan to increase it to the US data as well. This is basically a customer data which has information about all their addresses with the street, district, sub-district, city, state, and postcode. Now, the problem here is that this particular data is there's a mismatch in the data. The city does not match the state. Sometimes the postcode does not match the city. The district does not match the state or the sub district. So, and we are working on also what do you call, looking at the street data and also fixing that as well. We are actually working with this for an e-commerce customer in Chennai. They're like the Flipkart of rural India. So here, what we go and do is you can go and create a validation wherein we validate geolocation using pin code. We specify what are the different columns. Say, for example, the state column, you can just specify the name of it as state. In this case, everything is just the same, so we don't have to do much. So we specify that, and we can go and preview it. So what the system will now do is it will tell us exactly which are the ones where there are mistakes. Okay, and post those mistakes, we can go and all the data will be quarantined and it can eventually be fixed. What we are trying to do is now implement is that we will suggest the right rule, okay, to the user, and the user can go and specify whether it is whether they want to update it or they don't want to update it. The reason why I keep saying we will suggest is that we've spoken to a whole bunch of customers and most of them are very uncomfortable for a system to go and update data on its own. So that's the reason why we've decided to do suggestion and not go and make changes on our own unless and until it is specified by the user. Now, these are all cases where the city, state, and postcode don't match. Now you have city as Anaikat. Okay, this is the Google version of Anaikat. We use the India Stack data for from the post office. And their Anaikat is actually specified in Tamil properly as Anaikattu, Kattu. Okay, so in this case, we've targeted all those things as errors. Okay, there are also places where pin code doesn't match. In the case of Arcot, okay, the pin code does not match the district name. Okay, the city is Arcot and the district is Vellore. Okay, there are mismatches here. So this is another situation where we can go and identify geo data as well. Okay, geo mappings. Like I said, we are currently working on with addresses, which means that we will be able to give about an accuracy of anywhere between 500 meters to 3-kilometer radius, wherein we'll be able to say whether his address is correct or not and it exists or not. Now what we'll do is we'll look at another scenario where you can actually take multiple sources of data. You can actually play around with this. You can create as many sources as you want. But in this case, we'll just create 2 sources. One source is basically a CRM data, which has customer information. And then we have another data that is going to be, by the way, I'm using all files here. You can always use databases and other sources as well. Another is the ERP data that has hospital information about policies, claims, and things like that. We will go and create a scenario where we can clean this data. I'll also show you the capability of some of the other capabilities. We also have the capability to go and do custom modeling here. This is specifically targeted towards data scientists who want the data to be prepped up in a particular way. So we can use any of our models here, and you can prep data and you can keep it ready for data scientists to go and run their own, their own models, which means that you don't have to, because a data scientist typically spends about 80% of his or her time trying to clean data and trying to set it up. In this case, the system will automatically set it up and it'll identify if there's any bad data that is coming out of this. You can also identify that and eventually quarantine it, and the rest of the data can be pulled in and given to the data scientist. So that's possible as well. So what we'll do here is we will look at 2 different capabilities. One is auto-correcting geo entities, where there are multiple city names, you can go and correct them. We will also do something called classification, where we will specify. In this case, what we've done is we've created a training algorithm for all the symptoms and what buckets they fall under. Okay. And we have a procedure description that is filled basically by a doctor that says that this person had this kind of an issue, and we want to bucketize it as to what kind of a what should I say category it falls under. We will save that, and then we can eventually run this. So what happens is now the system will go and classify it, and it will correct the data as well. So I'll show it to you in a. Now what we can do is we can now go and combine the data. We can, the simple combination, we can make it as complicated as we want. We just combine the data now, and after combination, I'm just removing um, the common columns. If you don't remove, the system will automatically tell you that there are some common columns. What the system does right now is that it goes and classifies the data, and it also does the GeoCities validation as well. This is not the geo validation that we saw last time around. This is basically city names, spelling checks with respect to city names and things like that. So if you look at the data here, you can see what are the city names that have been specified. In this case, Chennai is probably spelled wrong here. You can correct it. These are not made up names. This is a library that we have, and within the library we've got different spellings that have been listed. So for example, Chennai can be identified still CH. If there is any other what do you call CHE, and beyond that you can actually go, and if there's anything wrong, it can identify it as Chennai. Beyond CH, it what do you call it clashes with another city like Chandigarh, so the system won't be able to resolve it. So we actually use fast text classification on this, and we identify spellings. So it is not a pre-written or a direct one-to-one mapping or anything of that sort. We also did the procedure description where we did the classification as well, where it is based on the procedure description. Here's the procedure description. We take and look at the keywords and we map it. Okay, that is what we do. And yeah, so this is the basic of what we have at this point in time. And then we have other models where, other features where you can go and create multiple users. You can schedule a workflow. You can do a whole bunch of other things. One of the things that I want to share with you is also give you a sneak peek into the new UI that we are building. I will share that as well. Are you able to see my screen?
Yes. Yeah.
So this is the new UI that we are building. It has something called a data quality index, which basically tells you what is the current data quality within the organization, the top errors. I also told you about the collaboration feature, where one of the things that we identified is for data quality to succeed, the businesses and the IT teams have to come together. Okay, only then can the errors be fixed, and data quality can become a very important part of the organization, and it can keep flowing. Because data quality is so crucial now that all the organizations are so data driven. Data quality is extremely crucial for companies. So one of the things that we've identified is what is the current business impact that so far with the errors that we are seeing, what is the data quality index, what are the top errors, what are the ones that have highest impact when the user, what is the total number of what do you call issues that are assigned to me, what is the activity stream, and things like that. It also gives you the a high level picture of what are the total number of errors per day, and total number of data processed per day, and the errors per day as well. And this is basically what we have, something called data profiling, advanced data profiling. So unfortunately, the current systems that do data profiling, whether it is Informatica or Talent or whoever, Oracle, whoever it is. The problem with data profiling is they just profile data and they tell you exactly what is the metadata perspective, whether it is a date, whether it is what kind of frequency they're able to see. And however, what they're not doing is that they don't really go and understand what is the relationship between this data. There are a few companies who started doing it. I think there is one company called Colibra who is doing that. They recently got funded. They became a unicorn as well. But one of the biggest advantages of doing what we call as guided profiling is it has to be very specific to the business. And what we do is we do guided profiling to understand exactly what the user is asking. We ask the user exactly what is the relationship between data. Okay, if there is a date column, say for example, I'll give you an example from the insurance sector. You cannot have the admission date, okay, of a patient cannot be after the discharge date. And what I'm telling you is a live example. Okay, it is happening with our customer, and we've identified all those things. Okay, so what's happening is that in this case, for us to identify all those kind of issues, we eventually look at the data and we specify that, hey, can you tell me what are the associated date columns with this? And we try to profile it, and we automatically create rules. Okay, and we suggest to the user saying these are the rules that we think should be added to your system, to this particular data source, right up when the data is being profiled itself. So that is another feature, and this is basically the output that you'd have from a data profiling module. This is going to be the new workflows that we are creating. The workflows that you saw, we're transforming them completely. And of course, these are all the places where you can do collaboration, you can go and talk to other users, you can fix errors, and there's a whole bunch of things that can be done.